Hello students, and you can see the loading screen right there. And welcome to today's lecture. And today's lecture is Lewis dot structures. Okay. And today's lecture, we're going to go ahead and retitle the second part here. Okay. And the reason that we're going to go ahead and retitle the second part is because this is going to be the lazy way of doing dot and cross structure. Okay, so earlier we did the dot and cross structure, okay, and that took a lot of time, and we had to draw so many dots and so many crosses, and it was exhausting, and it doesn't really fit with our perception of being lazy chemists. So there has to be another way. And luckily for us, we had a scientist, and his last name was Lewis. And he thought of a lazier way of doing this. Okay? And so I'm going to go ahead and teach you the lazy way of doing Lewis dot structures. And Lewis dot structures are lazy for a couple of reasons. One, it helps us to go ahead and, do half as much drawing for, actual bonds. Two, it makes it so that we don't have to look up in a table to see what kind of bond something has. And that we don't have to go ahead and scientifically figure it out. And we don't have to go ahead and break apart a molecule in order to figure it out. What we can do is we could just use these rules to lazily figure out how many bonds are going to be in a structure. And then the third thing is that it's relatively simple to tell a whole bunch of the important things about a molecule. So we can end up figuring out a molecule's shape, whether it's charged by doing the Lewis dot structure, and it just makes it easier. Okay, like it's so much easier. Your life is so much easier once you do Lewis dot structures. And it's just a preferred way of the lazy chemist life. That, doing this right here is going to make your life really, really easy. Okay. So, again, before what we ended up doing is that this is what a Lewis diagram is. Okay. And what it does is it just represents for us the bonds in an atom without necessarily having us draw all the electrons, okay? And you guys have probably seen me already slip up every once in a while with these. And those of you that are in class have probably seen that the front board is constantly covered in formulas that look like this. And the reason is that this is the laziest way, okay? And what's going to happen here is that every single line that we draw is actually going to represent 2 electrons. And those 2 electrons can either be from the same atom when it's a lone atom, or they could represent a bond between the 2 atoms, okay? And this is where our Lewis dots normally are. So we've been doing dots this whole time, and we're going to go ahead and get away from that, because it's going to be easier for us and cleaner for us to go ahead and draw them using dashes instead, okay? And then we're also going to cover this idea that there are unshared electrons, okay? And these unshared electrons are going to be important things for us to go ahead and count. And, when we go through a couple of the drawings here, I'll indicate them. But they're fairly easy. They're a pair of electrons. And we typically call them lone pairs. And they're usually represented by 2 dots. Or if you're really lazy, which I really hope that I'm able to get you guys to get to that point, that you're super lazy, you can also draw a line and have that indicate electron pairs. And that is my goal, to make it so that you guys are so lazy that you can't even be bothered to draw 2 electron dots. We all got to shoot for something, right? All right. And this is like the other formal way, and we've already done dots and crosses. Here, this is done like the non-Cambridge style, where they just indicated that an electron was a different color. Here, we would have the H's have X's instead of being a different color. Okay. And these right here are going to be the rules, okay? Or this is kind of like the rules that we're going to have, in general. And the first thing that we're going to do is we're going to go ahead and connect up all the elements to the central atom, all right? So all of our elements, we're just going to automatically connect them up to the central atom with bonds. Okay, we're not even going to be worried about anything else at this point. If there are multiple carbons, what we're going to do is we're going to start by bonding those together first. And the reason is that carbon likes to bond with itself. So it will usually bond with itself many times before it has to bond with something else. Then we're going to go ahead and count up the total number of valence electrons that we have in a compound. All right. So the next part is literal counting. Again, if you have troubles counting, I'm still going to question what you're doing in chemistry. But, in general, counting should be something that we have, available to us. Then we're going to go ahead and subtract out the number of electrons that were used in the bonds. The next step will be to add any extra electrons that we have not used yet. And we're going to add them to the outside elements. Okay? And typically what's going to happen is that each outside element can hold up to 6 extra electrons. And so we'll go ahead and add 6 extra electrons to each outside element. The only exception is going to be hydrogen, okay? And hydrogen's special just because it won't accept any extra electrons, okay? If we still have any extra electrons, what will happen is that we'll go ahead and put those on the central atom, and then we'll make all the atoms happy, okay? And remember, our happy atoms are going to be those that have 8 by double bonding and triple bonding to make, all of the atoms happy. So let's go ahead and work with that one right here. And we're going to start with a compound. Oh, why don't we start with the easiest of compounds, the ones that everybody knows, okay? We're going to go ahead and do H2O, all right? So we're going to do H2O, and this is a section we're not even going to use colors. Why? Because you guys should be all doing it in pen, and taking and using different colors is complicated, okay? So our first step that we're going to do, we're going to connect everything up together, okay? Oxygen combined with hydrogen. All right? So step 1, combine everything together. Step 2, we need to figure out how many electrons that we have, okay? H, we have 2 of them, and each H gives 1 valence electron. Oxygen, we have 1 of them, and each one gives 6. So that means that we'll have 6 and 2, which means that we need to draw 8 electrons total. Here, we have bonded up our electrons, and each bond has 2 electrons in it. Okay? Since each bond has 2 electrons in it, we'll go ahead and subtract those out. So that's what it means by subtract out your electrons that you've used. Right? So far we've used counting, multiplication, and subtraction. Okay? Now we have 4 electrons left to draw. Okay? We're supposed to draw those on the outside electrons, on the outside elements, which in this case would be the hydrogens. But as I said before, hydrogen doesn't take any extras, which means that we'll draw them on the central atom. Okay? And that means that we'll go ahead and draw 1, 2, 3, 4. Okay? And that's it. This is the Lewis structure for oxygen. Now, I'm going to be perfectly honest with you. I don't like drawing the dots. So sometimes you might see me also go ahead and draw it this way, with lines like that. And each line, remember, represents 2 electrons, which means that this and this are the same. Okay? Except that this one, the oxygen, looks better. Okay? Alright, so that's one example. Okay? So it's just following those same rules that we had from before. Okay? So let's go back over here. I'll give you a second so that you can go ahead and take a look at the rules again. Make sure you have them copied down in your notebook. And let's do another one. Okay? Let's do PCl3. Okay? PCl3. Alright. We're going to start the same way. We're going to draw P, and usually the first element, except if it's water, the first element usually is going to be your central one. We'll draw chlorines around. Okay, so notice we've done step 1, we've drawn our elements and connected them. Now we have to count our electrons. P, we have 1 P, and each P has some electrons. Let's see how many electrons we have. P has 1, 2, 3, 4, 5. Okay, so 5 electrons. Chlorine, we have 1, 2, 3. So chlorine, we're going to have 3. And chlorine has a total of 1, 2, 3, 4, 5, 6, 7. 7 electrons. Okay, so 1 times 5, that should be fairly easy for us to figure out. 5. 3 times 7 equals 21. We add them together. We're going to have 26 electrons total in this molecule. Alright? Right now, we've already used 1, 2, 3, 4, 5, 6. Okay? Those 6 went into the bonding, so now we have 20 more to draw. Alright? Now here, we have to draw them around the outside then. Okay? And I suppose theoretically, best practice would be to draw them as, dots. However, you guys know we're too lazy to do that. Okay? So we're going to go ahead and draw lines. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? So now we have 2 electrons left. Okay? Those last 2 electrons have to go on our middle one. Okay? So we'll draw them on our middle one. Okay? And then we'll just double check. We're going to make sure that each element has 8 electrons. Okay? So this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. This one has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. This one has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. This phosphorus has 1, 2, 3, 4, 5, 6, 7, 8. So it's also happy. Okay? And this is how we draw this molecule. And this is the Lewis structure for it. Okay? Well, this should be in there. But, there we go. All right. Now, let's go ahead and do another one here. Let's do carbon dioxide. Oh my god. Such a scrub. Going over. I already know the structure for carbon dioxide. I have it so memorized in my head as the structure anymore. Okay, so first rule. Let's go ahead and connect them up. Okay, and do yours a little better than that. Okay, Then what we're going to do is we're going to go ahead and count in carbon. We have 1 times 4. Oxygen, we have 2 times 6. So we'll have 4, 12, which means we need to draw 16 electrons. We have already used 1, 2, 3, 4. So subtract 4, we need to draw 12 electrons. Okay? So then we'll go ahead and draw them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now we've used all of our electrons. Now we're going to check to make sure that everything is happy. Okay, so this oxygen here has 1, 2, 3, 4, 5, 6, 7, 8. This one here has 1, 2, 3, 4, 5, 6, 7, 8. This carbon, however, does not. It has 1, 2, 3, 4. Okay, that means that we're going to need to move one of these pairs of electrons into a bond with carbon to help make it happy. Okay, so we're going to move a pair of electrons in with this carbon here, and now it's almost happy. It's not quite happy because it still only has 6. So what we're going to do is we're going to go ahead and move another pair. And now carbon will be happy. So that last step is just us moving some outer electrons into a shared bond to make it so that the central atom can be happy. And now that we know that, we can tell that, hey, look, carbon has double bonded to oxygen. Okay? And we're going to do one last example here. We're going to go ahead and do carbonate. Okay? And carbonate's special because it's one of those compounds that also has, or it's a polyatomic ion. Okay, and this will let us practice literally everything that we need to. So, first step for here, so we draw everything up together. Then we'll go ahead and take a look and say, okay, carbon 1 times 4. Oxygen, we have 3 of them, times 6. Which means that from here, we're going to have 4 electrons. Then we have 18. But I want you to remember that this exists as well. And when it's 2 minus, that means that we have to add 2 more electrons. Okay, so that means we're going to have to draw 24 electrons total on this molecule. Okay, so right now we've used 1, 2, 3, 4, 5, 6. So we'll have to subtract 6, which means that we'll have 18 electrons to draw. Since there's 18 electrons to draw, we'll go ahead and draw them on the outside. So we'll draw 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, we've drawn 18 electrons, so now we're good. We just have to count. And each oxygen, we can see right here, and this is the lazy way, each oxygen has 4 lines around it, so it's happy. But the carbon is not. Okay, and because of that, it's gonna need 1 more line. Okay, since it needs 1 more line, we can take it from one of the oxygens. Okay, and I guess we'll take it from this one. Okay, now this carbon's going to be happy. Okay, and it doesn't really matter which oxygen you take it from, because what's actually going on here is that double bond is being shared between all 3 of them. Okay, which means that it could be that this is the official one, and whereas this one is another option here. Okay, and these are what's called resonance structures of one another. So this is one option for your carbon. This is another option for your carbonate ion here. Okay, and those are just called resonance structures. Okay, And let's go ahead and give a definition here so that way I don't forget it later on. Okay, in a resonance structure, is a single representation of a molecule which has multiple states, or a mixture of states. Okay, and that mixture of states just means that, this shared bond is between all three, that shared double bond is between all three of the oxygens. So at some point, all of them are sharing that one extra electron to make this one happy. Okay? That's going to go ahead and close us out for Lewis structures. Lewis structures takes a little bit of practice to get, but once you get it, it becomes a fairly easy thing, and it can end up becoming so automatic that you prefer to draw things in Lewis structures than by using any other method to do any sort of arrangement or representation. All right? And then when it gets to that point, you're able to kind of figure out electronic configuration right in your head, which, if you're able to figure that out in your head, that's the true lazy method. Okay, but for now, we'll go ahead and close out. Remember, be lazy.